think it's better like that with the light off?
Yeah.
Yeah, because last week it was hard to see some of it. All right, is it going?
Yeah.
Got it, thank you, David. All right, so for the first one, this is number 1 off of the test. What was it, test 8, right? So if you missed something on test 8, here you go. A bag has red and white marbles. If the ratio of red to white is 7 to 5, what fraction of the marbles are white? Well, how many of them are white in the ratio?
5.
5. So it's 7 reds for every 5. So that means there's going to be 5 white out of how many total?
12.
Where do you get 12?
You add the number.
Yeah, you have to add those. You have to say, well, there's 5 out of every, the total would be 12. So that's 5 white ones out of 12 total. So 5 twelfths is your answer. All right, this one, good many people missed this one, but it's funny as I walk around, it seems like a lot of people got it. So I don't know what happened on the test. Sometimes I think maybe when you're taking a test at home and you get distracted, you know, it's easy to get distracted. You know, your parents call you to do something. I know I did that with my boys or something. And so you get distracted in the middle of it. Maybe that's what happened here. All right, so perimeter, what do we do to find perimeter?
You add up all the sides.
Yeah, you add them all up. So this part's the easy part. We've got 12 up there, right? And then we've got 2, and we've got 7 and 3. What's this one?
5.
How do you know?
Because the 7
right.
centimeters, I think.
Good, so this far along to here is 7, and it all the way adds up to 12, so this has gotta be 5. Okay, so we'll put 5 in there. What's this one?
5.
5. Or did I say, wait, is it 5? Yeah, it is 5.
It is.
All right, and then this is 2, and then this is 3, so this is 5. All right, good, I don't remember it being the same number, but. All right, and then we add them all up. This makes a 10, this makes a 10, so 10, 20, 2, 24,
34.
and then that 10 makes 34. So what would the unit be for that?
34 centimeters.
Centimeters, yeah, for perimeter. All right, for area, who's got a way that they did it? All right, David, tell me how you did it to find the area.
So I made like 2 boxes.
Okay, where did you make the cut?
Like with a 5.
Here or this way?
This
This way. Okay, so David said he cut it this way. All right, so did you find the area this one?
Yes.
That would be
5
5.
times 3.
All right, so he says that's 5 times 3, which is 15.
And then 2 times 12.
Okay, which is 24. What'd you do with those 2?
Add them up together.
And that'd be 39. What's the unit?
Centimeters squared.
Okay, did anybody else do it differently? I did it differently. Did anybody else do it differently? I did it the Eli method. This is what Eli said he did. So the last time we did one of these, I think. How'd you do it, Christian?
Is it when like you add up, like you like kind of dot it to make it kind of rectangular?
Yes. I just finished. I did it like that. I found the total area. I said 12 times 5, which is 60. And then I took away the 7 times 3, which is 21. And I still got 39. Or you could have done it like David, but cut it here and done 5 times 5, and then 7 times 2. So 5 times 5, which would be 25, 7 times 2, which is 14, and there you get 39. Okay, any questions about that? Y'all good? I find that a lot of times students will have trouble with the missing sides or just mislabeling it. That causes them to miss it. But all right, number 7, 2 angles of a triangle each measure 40 degrees. So we've got an isosceles triangle situation because you get 2 of the angles equal. So we got 40 degrees and 40 degrees. What is the measure of the third angle? What's the sum of all the angles in a triangle?
90.
Not
Or
90.
180.
180. Remember, when in doubt, just say 180 because there's a whole lot of things that are 180. So if the total is 180, let's take away 80. There have to be 100 degrees in this last angle. Okay? Find the area. Good many people miss this one. Okay? What's the formula? Eli, do you remember the formula for a triangle?
Base times height.
It is base times height, and then one other thing. No.
1/2.
It's a half because look, if I multiply, watch this, if I multiply this base times this height, I would be finding the area of a rectangle. Yeah, so see this base times this height would give me that whole rectangle, so I've gotta take half of it to get the triangle. Does that make sense? Okay, all right, so we're gonna do 1/2 of the base, which is 24. How do I know that's the base?
Because
You
it's
can
the
just
bottom.
divide it.
Well, it may not always be what's on the bottom, because I've seen some math problems where they'll draw it and the base is actually on the side. How do you know the base? Did you start to say it then? It's the one that it's the perpendicular is drawn to. So you could actually use 10 as the base, because you could say, well, there's a perpendicular line drawn to it. As long as the base and the height, they have to be perpendicular to each other. So you could use 24 and 10 and switch it around and have this be the base, right? Could this be the base?
Yes.
And
Or
actually,
if it was,
there isn't a height to it though. Only if they gave me another height to something else, right? So you determine the base by the base and the height have to be perpendicular to each other. All right, so the height here, if the base is 24, the height is 10. The way I did it is I went ahead and took half of 24, which is 12, and then you multiply that by 10, and that's 120. Now, what's the unit for that one?
centimeters.
Almost.
Or centimeters squared.
Centimeters squared. Yeah, because it's unit, it's area. And think about it too, the 24 is centimeters and the 10 is centimeters. What's a centimeter times a centimeter? A centimeter squared, square centimeter. All right, right here, the way I would do this one is just multiply 37 times 4. I would make it easy on myself. I would just do 37 times 4. 4 times 7 is 28. 4 times 3 is 12, plus that's 14. Then I would say, how many numbers are after the decimal? 1, 2, 3, 4. So I would go 1, 2, 3. I'd have to add a 0, 4. That's my answer. Right there. Okay? Because when you multiply decimals, you really don't even need to worry about the decimal till the end. Okay? All right, here when you're dividing this, I think some people forgot the decimal and maybe misplaced the decimal. I'm not dividing by a decimal, so I just kind of ignore it for a second here. I can go ahead and bring it up, but I'm not worried about it. There are no 6's in 1, but there are 2 in 15 and 6. Okay, so there's your answer, 0.026. So grab the test that I passed back to you, and if you want to look at, you should have this on your paper. You should have the correct answers on your paper. Make sure you have that, and you can put that somewhere to where you can look at it later. The point of a test is to make sure you learn it. So if you missed it, you need to spend some time, go back and say, why did I miss that problem? So that you can see if you need any help or whatever. Yes, what?
What do you put on there?
Yours, your mom emailed to me, so I emailed it back to her. I didn't have a physical copy. So you can ask your mom if she can print that out for you. All right, so we're gonna do a little bit of stuff on the board, and then we're going to do a cutting thing. Did y'all remember to bring scissors? I emailed parents last night. Some of you may not have found out, and that's okay.
I think I left mine in the car.
Did you?
We have a lot of scissors.
Do you have a lot of scissors? Okay. Well, we may need to get some scissors in a minute. I have one pair of scissors, but I don't have a lot.
We have
And it's so hilarious. We were talking about scissors the whole time. Like, remember your scissors, you know, I left them in the car.
You left it in the car. It's okay. Well, we might make a run. David can go see it. If we can borrow some scissors. Nah, we'll wait just a second. I'll let them, maybe when they're drawing it, we have to draw something and cut it out. And it's in lesson 58. So we'll do the first one, and then that'll give us kind of a little break from writing for a minute, okay? All right, so this is lesson 57. And our first example, okay. I'm gonna write up here some things that they have, let me see, on the board. I'm gonna write some things up here. You do not have to write what I'm writing right now. Okay, so just put your pencil down, just kind of watch. Sometimes when you write, it helps you, but sometimes it hurts. I just want you to look and use your brain for a second. Okay, if I had this problem, can y'all see it okay with the light out?
Yes.
Okay. All right, so if I had this problem, I want to write it out the long way. Okay, what does that 10 to the 6th mean on the top? It would mean 10.
10 times 10 times 10 times.
All right, how many 10s would there be?
10. I mean, 6 tens.
There'd be 6 of them, right? 1, 2, 3, 4, 5, 6. How many would there be on the bottom?
3.
And then cross multiply.
Okay, not cross multiply, but cross cancel. Right? All right, so canceling is just dividing, right? When you simplify fractions. All right, so let's divide some of those out. 10 divided by 10 would be 1. 10 divided by 10 would be 1. 10 divided by 10 would be 1. What would be left?
1,000 over 1.
Yeah, or just 10 times 10 times 10. Let's just leave it like that for a second, which Dave is right, it is 1,000. But let's just look at the exponents for a second. Look at the initial problem. 10 to the 6th divided by 10 to the 3rd equals 10 to the 3rd. Is there a shorter way than having to write all that out to know that it's going to be 10 to the 3rd? Let me put another one up here. What if I
That's
did?
just divide it by.
Is it dividing? Let's see what the answer to this one is. You can be thankful I'm not making you write it. Okay?
Subtraction?
What about subtraction?
Well, minus 3 from, take away 3 from 6, you get 3 left, but then on the other one, you have 5, and when you take away 3, there's 2 left.
Very good. So you're subtracting the exponents.
Not
So this is Lily's conjecture. We will name it. Lily's conjecture is that if you have something like this, you can just say that's the same as 10 to the 6 minus 3. Just subtract the 2 and then you'll have the answer. Well, let's try to see if she's right. Let's see if that carries through. Sometimes you can have an idea and it doesn't keep working, okay? So let's cancel these out. What's left right here?
2 tens.
So that's 10 times 10, which is 10 squared, which David would tell us is 100, right? Let's think about Lily's conjecture. What would you do to get that 2? 10 to the 5 minus 3. And it worked, didn't it?
Yes.
Would it work again if I reduce this one another time? Let's try that. I'm not gonna write it all out. Let's just think in our head here a second. If I have 4 of them on the top, multiplied, and then I have 3 tens on the bottom, 3 are gonna cancel, right?
Yes.
And how many will be left on the top?
1 10.
1. So that's gonna be equal to 10 to the 1st. So would that be the same as what Lily said, 10 to the 4 minus 3?
Yes.
Yeah, it is. All right, I want to go one more. I want to see how they did, and then they jumped over right. All right, how about this? What does Lily's conjecture do for a problem like this?
That's. It wouldn't work because that would just be 1 because it's.
It actually does work.
So it would just be 1.
All right, so y'all know the answer is 1, so I'm gonna jump way over here. Because anytime you divide things that are the same, like 5 divided by 5 is 1, 100 divided by 100 is 1, right? Y'all know that. Anytime you divide the same thing, you get a 1. But Lily's conjecture was 3 minus the 3. She would say that's 10 to the 3 minus 3. Well, what is 3 minus 3?
0.
So that means that's 10 to the 0.
Which is 1.
But guess what? 10 to the 0 is 1, so it still works. Okay? I'm going to go one more, and let's see if it still works. What if we did 10 to the 2 over 10 cubed? Does it still work? All right, let's see if we can figure this one out. Let's write it out long way. That would be 10 times 10 on the top. What would be on the bottom?
10 or 15.
What would I cancel?
The 2 tens.
These lids are really hard to get off. Alright. One. Now wait a second, is that a 0 in the top?
Yes.
Well, when I divided how many tens are in here, 1, how many tens are here, 1. So there's a 1 in the top, right? So that's equal to 1 over 10, okay? But Lily's conjecture would be that's 10 to the 2 minus 3. What's 2 minus 3?
-1.
So that's 10 to the -1. So hold up, we just learned something. 10 to the -1. So here's something we need to know. 10 to the 0 is equal to 1.
So like 10 to the -2, would that be -1 over 100?
Yes. Very
We're
good.
making this a little more complicated than it should be.
No, well,
We're
it's
just like
not
going
complicated.
in like different ways, but it's the same as
It is, they're the same. It's important to know that they're the same. So David said, what about 10 to the -2? Or actually, you said, what about, yeah, you did say that. All right, I usually tell students, well, actually, before I answer that question, I'm going to give you another pattern that's a little smaller and easier to write. 2 to the first is 2, right?
4.
What's this? 4. What's this? 8. What's this?
16.
16. Let's go down the other way. What'd you say for the 0? 1. A lot of students have trouble right here because they're like, I'm not convinced that something to the 0 is 1, and they don't like the way this works out. But if you look at it here, there's a pattern here. Did you see how going up these numbers keep doing what?
Doubling.
They double. So that means let's turn it around and go backwards. What happens as you go down?
They
Or
subtract.
subtract.
You're not subtracting.
Or
Wait,
So
divide.
they're dividing. Dividing by 2, dividing by 2, dividing by 2. What's 1 divided by 2? Or no, 2 divided by 2 divided by 2 is 1, right? So 16 divided by 2 is 8, vote with me. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. What's 1 divided by 2? 1 half. So that means 2 to the -1. Look at these patterns. 4, 3, 2, 1, 0, -1. Look here, 2 to the -2. Would have to be divide that in half.
1/4.
1/4. So what would 2 to the -3 be?
1/8.
1/8. So you see that pattern, but when you do negative exponents, you're not going to want to sit there and write this down, are you?
Yeah.
You're not going to want to sit there and do it. So we need a pattern, and what Lily gave us is going to help when we have these problems. But we need a way to know, what does a negative exponent mean? All right, Dana?
So, I saw people saying like -1. I was saying we're doing like 10.
Oh, and it'll work with any power, but yeah, I switched because the 10s are just longer, right? And this would be something you can do for yourself later. Let me show you a way that you can look at it and see. You're used to negative numbers, right? Y'all are all used to negative numbers. But here, this is not a negative number, this is a negative exponent. None of these numbers are negative, which is a little mind-blowing because you're like, wait, but they have a negative in them. No, the exponent has a negative in them. This is really, really important. So when you see a negative exponent, I want you to think 1 over. When you see a negative exponent, don't think negative, think 1 over. And then it's 2 to the first. This means 1 over 2 squared. 1 over 2 cubed. So what if I gave you here? Look, let's go back to David's original question here. That would be, what would this mean?
That would be
What I said, 1 over
1/100.
10 squared, which is 100. So what would 10 to the -3 be?
10
1 over
or
10 cubed.
Which is 1
All right, here's a different one. What would this mean? You write it on your paper, what you think that means. It says x to the -3. You write what you think That means, based on what we just did, x to the negative 3. Lay your pencil down when you put a guess down. I'm not even going to look at it. You don't even have to stress. I'm not even going to look. And it's okay if you missed it. This may be the first time you've ever seen this, and that's okay. There you go. All right. So what did I tell you to write when you see this? 1 over x cubed. How many people wrote that? That was your first introduction into negative exponents. Let's try another one. What if I told you to write b to the negative 2? B to the negative 2. All right, what do you write when you see a negative exponent? 1 over. This part says 1 over b squared. Raise your hand if you put 1 over b squared. Look at that. We tripled it. All right, let's go again. What if I put z to the negative 10? What do you write when you see that negative exponent?
1 over.
1 over z to the 10. How many got it that time? Awesome. Good. Okay, so how many of y'all have ever had negative exponents before?
Never had it?
How many have you ever, anybody in here, has anybody ever had them ever before? No. Wow, that's exciting. I get to be the first person to talk to you about negative exponents. That's pretty cool. All right, so, you didn't think that was exciting?
It's
Like, your parents have a baby book, or some of y'all that they write down like your first steps, like this is important, you should write this day down, it's your first experience with negative exponents. You need a picture? We should take a group picture. Lily's like,
I feel
We were
like
going through boxes last night.
Negative
That was my
exponents.
first haircut.
see, and today, you didn't even know coming in here that today was gonna be monumental for you. Like, you should go home and write something like this, or take a picture.
But the thing is, like,
What?
you just understand it so clearly. Like when you first understand something, you feel like your mind's blown. For me, my mind right
It's a
now.
little painful. Okay, here's the actual example. That was all the background knowledge, okay? Here's the actual example. Write the answer to this. A is 2 to the 0. You should very quickly write what that equals. And it's not 0. What is it?
It's 1.
It's 1. Remember, anything, I'm going to leave this up. Anything to the 0 is 1, except 0. Because 0 to the 0 is not a 1. But any other number to the 0 is 1.
So
All right, B. Do I?
Will negative 1 to the 0 be 1?
Yes, if it was written like negative 1 to the 0, that's 1. In algebra, my students sometimes, they'll have this huge problem. Well, maybe not that big. It'll fit on paper. But anyway, it's maybe this big. It's like a fish story. You know, that fish was this big. It's a huge problem, okay? And it'll be in parentheses and raised to the 0, and they're like, yes, because it's just equal to 1. Doesn't matter what. Anything to the 0 is equal to 1. All right, B, write down what you think this means. 3 to the negative 2. Who's brave? Let me see hands if you're brave and you're like, I think I may have this.
This is my first time.
That's okay, it's everybody. All right, Christian, go for it. What do you think? 1 over, I'm gonna say 3 squared, but he's right, that simplifies to 1/9. Is it negative? No. This is a negative exponent, not a negative number.
Would you write if you had just a question like that? Would you write it in the simplified form or just?
I'd write a simplified form. The only reason I took the time to do this is so you can see where I got it. Because if I wrote 1/9, some people would be going, what's she doing? Yeah. All right, C. C, I'm gonna do 10 to the negative third, and we did that up here somewhere already. 10 to the negative third. Eli, what do you think? No? What did Eli, let me ask you, what do you think, what do you write when you see the negative? There you go, 1 over. And what goes under? 10 cubed. That's right. Which is 1 over 1,000. Violet, did you get it? Yes. Phil, did you get it? Look at that. Very good. All right. Let's look at. Okay. So the other thing that we need to talk about. Don't write this part, but just think. All right. You ready? Usually, when we multiply by a number, what happens? Like I take my original number, I multiply it by something. It usually gets bigger, unless I multiply it by a number that's, well, 0 or less than 1, or negative, right? If you multiply it by a half, that number's gonna get smaller, right? Yeah, a fraction, a decimal. Well, look what happens when you multiply by a negative exponent. Well, let me just kind of make one up for a second. What if I said, no, that's okay. We'll go on with there. Because I mean, I better go with this one. All right, it's 4.63 times 10 to the negative 8. 4.63 times 10 to the negative 8. All right, you would expect that that number would get bigger because we're multiplying.
Oh,
But for this, yeah, don't do it yet. If you were doing, you remember when we did scientific notation before?
Yes.
And you did this? If it were a positive 8, does anybody remember what you would do to get that into standard? Do y'all remember?
Yeah.
Jake, you remember?
Oh,
Yeah, you're just gonna move the decimals 8 times to the right. So 1, 2, 3, 4, 5, 6, 7, 8, and I fill in zeros. Okay? It's a really big number. But here I move it to the right. Where do you think I'll move it here? To the left. Because when you multiply by a number that has a negative exponent, you're really dividing it. Because negative exponents are fractions.
If you write the 8, so you 1 over 8 times 10, it would be 1 over 100 million.
Yeah, this is a tiny number. This is a tiny number. So I'm going to come way over here and write the 4.63. But I've got to move it 8 to the left. So I'm going to go 1. Then I got to add a 0. 2, 3, 4, 5. I still don't have enough room. 6, 7, 8. That's equal to that number. Which, if this is what? Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, 10 millionths, 100 millionths, billionths, 10 billionths.
So
This is 463 10 billionths.
So technically, you just add 1 millionth to it. Because it's.
Oh, because it's on the other side.
Because, like, when you said, 10 to the negative 8, it would be 1 million. So you just add millions.
I guess so. I don't know that I would even go through that thought process. I would just move it that many times. I would write that number, find that decimal, and move it that many times. The key that you need to know is this moves to the right, this moves to the left. If the exponent of 10 is positive, you're making it a big number. It's going to go to the right. The other way is going to go to the other direction. Okay? All right. So if they give you a really small number and say put it in scientific notation, then you could do that. All right. Here's example 4. This is asking you to compare 0. So you're going to put a greater than, less than, or equal to, and 1 times 10 to the negative 3. 0 and 1 times 10 to the negative 3.
Which one's bigger, Sam? Which one's bigger?
Yeah, it's asking you which one's bigger. Which one's bigger? What do you think? This number, if I write it out, here's 1. Where's the decimal in 1? At the end of it. So I've got to now move it how many times?
3 times.
3 times. Do I go to the left or the right? Left, because I'm making it smaller, right? So I'm going, here's another way to think of it. On the number line is the negative direction. So I'm going to move 3 times. So here's 1 time. Here's 2 times. Here's 3 times. So this is 1,000 and this is 0. What do I put in between it?
You put in,
Is 0 less than that, or greater than that, or equal to that?
Zero's less.
It is less than that. So they're trying to kind of trick you with this one and make you think this number is negative. This number is not negative. Does that make sense? Okay, that's a little mind-blowing. Okay, like when the first time you learn fractions, the first time you learn negative numbers, right? It's a little mind-blowing, but y'all got it. Y'all did a really good job. And to reward you for your great job, we get to cut. When y'all were little, did y'all like cutting? My boys always did. Sometimes when they were just bored, I'd be like, here's a pair of kid scissors. Let's cut some paper. And they were loving that.
honestly, I just thought it was so satisfying.
It is.
It's like, yeah. There was just this one scissor in preschool. It just made a sound. It was so
Was it
amazing.
satisfying?
It was just so amazing.
I get it. Well, now we
Everybody
know.
wanted to use that scissor.
Now, Lily just admitted she liked to cut her hair when she got scissors, so I'm gonna make sure I don't put, and just so y'all know, these scary looking scissors I have, I use them in the garden, and they were the only ones I could, I know, I pulled them out and I was like, they're gonna wonder what in the world is happening with those scissors, but I use them in the garden. Alright, hey, tell them. Alright, here's,
The boys.
this is a square. What do you know about a square?
They're two-dimensional.
Okay, they're two-dimensional. What about all the side lengths?
They're equal.
They're equal. I cut this out. It was very satisfying when I did it. Okay. This next lesson talks about lines of symmetry. Okay. So how can I fold this so that I get two equal sides?
Fold it in half.
All right. Let's fold it in half this way.
Oh, you got like the edge.
Like a diamond.
Oh, like a diagonal. We'll try that in a second. So that line, you see the fold where I folded it? Okay. That's a line of symmetry. If I fold it on the line of symmetry, it's equal on both sides. Okay. So I could do it this way, right? I have another line of symmetry. David said, I'm a little nervous because maybe I didn't do such a good square. We'll find out. Oh, I think you did. I did. There's also a line of symmetry because it's equal on both sides. Now, what if I had more on one side and on the other? Would it be a line of symmetry? No. Okay, so this, you could do it again here. So it has a bunch of different lines of symmetry when it's a square. I'm going to take this triangle. This is not an equilateral triangle. Okay, it's isosceles. Okay, so how could I fold it to get a line of symmetry? Violet says she knows. Be careful, Violet.
No questions, but all the questions.
All right, looks good. Any error would be my cutting of the triangle. Do you see her line of symmetry?
Yes.
All right, is there another line of symmetry? Like, could I do it this way? No, because it wouldn't be the same on both sides. Any other way that I could fold it? Anybody got one to try? It is kind of tiny, yeah. There isn't another way that I know of to do it. All right, what if it's an equilateral triangle? What would you do to get a line of symmetry for an equilateral triangle? Okay. That's it. Good. Good. I actually measured it out too, so
He's
hopefully.
done the unthinkable. He's done it.
Are you a perfectionist, David? Okay, so David got us a line of symmetry there. Is there anything else you could do? Well, what if you did that, since it's equilateral, couldn't you do it the other way?
Yes.
Okay, so it's got another line of symmetry. And couldn't we do it with the other side?
Yes.
And we have another line of symmetry. So different shapes have different lines of symmetry, different numbers. I want you to open your book to, oh wait, that's the wrong one. PG. Let me find it. 390 is correct. wouldn't mind going and getting a couple pair of scissors, after I give you the directions, that way you don't miss the directions. All right, 390.
You don't supposed to read us about 392.
Okay, y'all ready? Page 390, you need paper and scissors. I brought paper. Fold a piece of paper in half, so you're gonna fold it in half, okay? Then you're gonna cut out a pattern all the way down the side, on the folded side. And then you're gonna go open it up and see the line of symmetry. Then we're gonna do it again with another piece of paper that'll have a double line, 2 different lines of symmetry, okay? So you're gonna get a piece of paper and follow the directions and you'll make your creation. David, you can go ahead and go get some scissors. Girls, you get to pick your color.
How many do we need? How many do we need?
I don't know, grab a few. They can share, so maybe 2, at least 2. Christian, what color would you like?
I like a weird piece.
There's blue. How's that? You wanna pick one for David too? Pick one for you and pick one for David.
Hey, actually, this is a good color.
It is nice. You're good. Okay, go ahead and do this. I guess so, yeah. It just says in half. It doesn't say.
Anyway,
Hang on.
I'm gonna fold it the long way so
Okay, I just
I
do this.
Alright, do it that way. See what you get. And I have a pair of scissors if you would like to use mine. David will be back real quick, I'm sure.
the blue graphic scissors.
Let's see.
I don't know.
You can get another one for your second creation. What would you like to use second? Why do you have to? Violet. David, you want to go ahead and get your second one. Eli picked you. You can pick your second. And then you can have yours. Okay, so we're gonna do it twice. One with just 1 line of symmetry and the other with 2 lines of symmetry. Okay? Oh wait, David, you gotta fold it in half. Fold it in half. There you go. So follow these directions. Fold it in half. And then you're gonna cut a design down the fold. Yes, you may have some scissors. Okay, here's another one. It's either the garden pear or the kids pear.
Well, these are kind of like.
It's like orange.
Should I make that?
They've cut a lot of tomato plants. Yeah, go ahead and do it. No, don't cut it like that. Look, right here, you're gonna cut along the edge. Look guys, look up here. On the folded side, you're gonna cut a little design
Like,
all the way down. Do what?
like,
Yeah, and you're gonna kind of cut it around. So that when you open it, whatever the thing is that you cut out. Sure. It's gonna end up with 1 line of symmetry. You cutting it on the fold? Wait, cut on the side. So cut it like all down through there. So that when you open it up, it's gonna, there you go, you got it. Oh, that looks cool. Well, it's cool, it looks like a vase. Here, this is your thing. This is your creation. Look, here's David's. When we opened it up, it was like this when he cut it out, but when we open it up, do you see the 1 line of symmetry? It's like a vase. So it looks like, or a dude with a hat on.
a dude. That's actually an instant.
Oh, Violet got a heart.
It looks like a snake, so hard.
Oh, yeah. It looks like an icicle ornament. You should hang that on the tree when you go home. And put on there, today I learned negative exponents. Yes, you should. You should do it. Alright, these are good. Alright, for your second one, you have to fold it and fold it again. You're going to fold it twice. And you're going to cut your design out of the both folded sides. The corners are open. Oh, cool. That's like a, yeah. That's really cute. Okay, I'm going to hold it up so Candy can see it. Hope Candy can see that. This one you're going to fold twice. Kind of like you're making a card. Yes, you do it on that side. So that all the corners are down here. Yeah. And you cut it like that. Yeah, fold it that way and then fold it again.
What
So
about
I would put on this side, right?
Yeah. Yes.
That's it?
Yeah.
Yeah.
You never folded paper before?
fold paper? Mix it.
See, it works out well because like Christian said, after you learn negative exponents, your brain's a little like smoking hot. So we needed to do something different.
It's not that it's smoking hot, it's just like it's kind of,
It's
like
what?
the excitement kind of,
Uh,
it's fun to learn, but like,
it's fun to learn new things, I think. It's kind of hard sometimes in math when you do the same thing over and over and over and
I
over.
don't make mine.
That part's not fun. Oh, no, they came undone. Oh, you know what? Because you cut out the corner, but that's okay, because you've got a cool little thing here.
What if I have this?
I don't know, but it's kind of cool looking. Now you have ornaments, you can say David learned negative exponents on December 6, 2023.
make sure not to make it ornament, guys. This is an ugly.
Oh, I can't wait to see what you got. Oh, that is so cool, can I show you? Look, y'all, what Lily did. It's an X for algebra, her love for algebra and variables. Yes, it is. I know you love it. I know you love it. It makes me so happy. So it's another ornament for her to put I love algebra on her tree. It is. It would be a butterfly. It's too cool. Oh, cool. That's a tree. Violet learned negative exponents. July 6, 2023. I know you're gonna do it. Don't say you're not.
What?
I don't have an extra piece. You can do a really small one. Make a small square. All right, yeah. I do not know what time you have to do.
Was it 2 o'clock?
I do not know that. Your mom didn't say a time.
No,
He did. He's like, go. We gotta go. Okay, good. At least you got to do the cutting. Look, we're making a video of this, and I can send you the link, so you can see what the last part is, because we are about to do another new thing.
keep my paper.
Sure, because I know you want to put them on your tree. I'm gonna come see you, and I'm gonna look when I come to your house. Okay, finish up what you got. Y'all can keep your papers, or you can put them in that trash can when you go out. But we do have another thing to learn in this lesson that I think is pretty interesting. It's not super hard. It's called functions. But if you tell if you have an older sibling, you tell them you learned about functions today, they might roll their eyes and be like, huh? Because they don't necessarily like it. Yes, thank you. All right, thank you, Bill. Oh, very nice. This could have been, this could have been a great day to make paper snowflakes. We could have done that.
My days are coming
So
back.
everybody, let's get the scissors. I'm gonna get my scissors back. Pass to David the scissors that he let us borrow. Hey, she's coming. Oh, that's okay. David got us some. All right, so pass down to David his scissors, and we'll make a scissor pile right here. Very good. Thank you. And you can keep your paper. All right, now go back to your notebook. That was your lesson on symmetry. I don't think we need to do problems that we write on symmetry. But for functions, this is example 2, and this is lesson 58. For functions, I've seen some books call it a function machine. Okay, it's where you put some value in, and there's a function, some sort of rule. Okay, so like the function is the rule. And once you put that value in, it uses the rule to determine what number comes out. Let me give you an example. All right, y'all have to put the paper down, okay? And pick your pencil up, because we're going on to something else. Okay. All right, so if I put in the number 0, let's say I'm going to do a function that determines how much money I've earned, okay? Let's say I work at a job and I get, I'm not going to tell you how much per hour. You're going to have to figure it out. I get at some job, Chick-fil-A or whatever, I work 0 hours. How much do I get on my paycheck? Zero, okay? What if I worked 1 hour and I found out I earned $10? And what if I worked 2 hours and I earned $20? And what if I worked 3 hours and I earned $30? Have you figured out how much I make per hour?
Yes.
10 per hour. So the rule would be that my pay is equal to 10 times the number of hours I worked. Now, at this point in your book, they're not going to ask you for the rule, but you can figure that out, y'all just did. But they are going to ask you to fill in the table. So what if I gave you this and said, what is the missing value?
40.
40. Y'all would know because you could look at the other numbers and figure out the pattern and find the one that's missing. That's what this lesson's about. So you fill this one out. Here's the in. You write this one down. Here's the out. It's 3, gives you a 9. 5 gives you a 15. 7 gives you a, I'm not going to tell you. And 10 gives you a 30. You have to try to figure out what the pattern is or the rule is so that you can fill in the missing box. You write it on your paper, don't say it yet, but write it on your paper when you think you know what it is.
This only works 99.9% of the time because in real life, because 40 by 3 you get promoted.
Yeah, that's true. Not usually after 3 hours, but then there's taxes, right? So taxes.
So technically it's like, yeah. So you're not really getting $10 per hour.
Oh, wait, let's see. Yes, yeah. Okay, so if, what'd you figure out, how'd they get from 3 to 9? Is it adding 6?
It's multiplying.
Okay, it's multiplying by 3, multiplying by 3, multiplying by 3, so the missing number is 21. Okay, so that lesson, that's all there is to that lesson. Symmetry and functions. Okay, so I don't feel like that's going to be a hard lesson for you to do. Do what?
We're going.
We are headed to 59.
Oh, 5.
All right, 59 is adding numbers on a number line. I feel like y'all have done this probably, but there are a few new concepts in it, so don't turn your brain off and think, oh, I've got this is easy, whatever. It's not that hard, it just could be new to you, okay? All right, we talked about integers, okay? Those are your whole numbers and their opposites. So your negative numbers are included in those. All right, I'm going to draw a number line. You don't have to write this yet. I'll tell you when you need to write. Here's all right, these dots represent the integers. And they keep going forever in both directions. What does the set of integers not include? What types of numbers are not integers?
Fractions.
Fractions,
Yeah, decimal.
decimals, parts of numbers are not integers. And these are all integers, okay? Now, these also in your book, math books, they'll call them signed numbers because 1 and, oops, I should have put a negative there. 1 and -1, 2 and -2, 3 and -3, okay? The positives are on the right side of 0, the negatives are on the left side of 0. So I may ask you about the number 3, or I may ask you about the number -3, but in this lesson, they're going to start asking you for the absolute value of a number. So I want you to write that term down. Absolute, write it down, absolute value. This can be very tricky for people when they learn it, and it's not that hard. Okay, so write absolute value down. Absolute value. All it is the distance from 0. It's just the distance from 0. Okay? So, how do you write absolute value without having to write that whole word out? We wrote the 2 words out just a second ago. This is how you write it. These lines are absolute value lines. They look like ones, they're just longer. Yeah.
That's the best thing to see out.
Yeah, you like that part, don't you? All right, the absolute value of 3, all it means is how far is 3 from 0? Well, let's look. How far is 3 from 0? 1, 2, 3. It's just 3. Right? All right, write that one down. Absolute value of 3 equals 3. You may be like, well, that's easy. Okay, good. What's the absolute value of 2? 2. What's the absolute value of 1? Why 1? What's the absolute value of 0? 0. It's 0 from 0. It lives right there, right? What about the absolute value of 100? 100. Okay? David? Well, it'll come up later. There's a lot of rules and formulas and different things that use it, so you kind of have to understand it. But it's not that hard. Here's where it gets a little more difficult, but not really. How far is negative 3 from 0? Is it negative 3? Is it 3? All right, let me ask you. How far do y'all live from David's house?
30 minutes.
All right, give me a number of miles. Estimate. I'm going to say for me it's like 15 miles.
It's about 22 miles.
22 miles,
Yeah,
yes.
25.
5 miles.
22 miles.
Did you notice something about all those numbers? Nobody said negative.
So 3.
Would anybody live a negative number of miles from here?
Yes.
So distances, this is really important. Distances, write this down, are always positive. Okay, distances are always positive. So when you do absolute value, you're always going to get a positive number. So how far is negative 3 from 0? Let's count. 1, 2, 3. How far is negative 100 from 0?
100.
100. So that part of the math lesson will be pretty easy, right? But here's the first example, and believe it or not, this can be a little tricky sometimes. Write this down. Absolute value, 3 minus 5, absolute value. Write that down. The absolute value of 3 minus 5. Here's where a lot of people get tripped up. They forget their order of operations. What does order of operations say you should do?
Parentheses or commas.
Yeah. These, when it says parentheses, as you get older, you'll learn that grouping symbols, there can be lots of grouping symbols. Okay, you can have parentheses, you can have brackets, you can have absolute value symbols. All it means is do those first. So what you got to do is go inside of there and do it. What is 3 minus 5? Negative 2. But then I take the absolute value, and that's 2. I have a lot of students who will think, oh, absolute value means make it positive. No, it does not mean make it positive. It means how far is it from 0. Don't think it means make it positive. That's not accurate, okay? Because then if you get here, you might go, oh, that's 3 plus 5. You see? If you're thinking, oh, I just make everything positive. No, you don't. You have to simplify 3 minus 5. You get negative 2, and then you take the absolute value. Okay? Does that make sense?
Yes.
All right, and you'll have plenty of those on there. We do have another example, so don't pack up. We got this. One more, and I don't think this will be hard either. Let's show this on a number line. Okay, so I'm going to do this as example 2. And then we're done, okay? Negative 3 plus 5 on a number line. Actually, we're going to do negative 5, I think. Yeah, negative 3 plus, yeah.
Wait, what?
0.
No, we're going to do negative 3 plus positive 5. All right, so draw your number line. You always start where?
In the.
No, on the number line.
0.
With 0. Okay, so I'm going to start at 0. Okay? And then it tells me to go -3. Which direction is -3, left or right? Left, so I'm gonna go back 1, 2, 3 to -3. So what your book says to do is to draw an arrow from 0 to -3 and then stop right there, okay? Then it says to go back to the right, how many? 5. So I'm gonna have to go to the right 5. So I'm gonna go 1, 2, 3, 4, 5. So I'm gonna start there where I left off and go back to the right 5. What number is this? 2. -3 plus 5, I went to the left 3, and then I stopped, and then I turned around and I came back 5, and you can see you end at 2. So that's equal to 2, okay? I highly suggest you checking these as you go, because it's gonna help you understand sign rules as we get to those. But this section, it's basically absolute value and drawing number lines. I think y'all got it. All right, could you pick up the scratch paper and put it in the trash can if you don't want it? And then, Dave, will you turn the video off? Violet, are you done with these? Okay, will you